Theoretical physics is a very varied course. In essence, what you're doing is you're taking known laws of physics and we're studying them at a deeper level. So, for example, the courses that we offer typically at postgraduate level in theoretical physics are the likes of quantum mechanics. So that's understanding how the smallest elements of our universe, how the dynamics of that evolve with time, and how we can better understand the physics of the very small, if you like. And theoretical physics then goes from the physics of the very small to the physics of the very large. So we also offer courses in general relativity, in cosmology, so that's studying obviously the universe at the largest scales. But of course in cosmology, it's interesting, cosmology requires that understanding of the smallest scales to the largest scales. So it's really all encompassing, trying to get a deeper understanding of every aspect of physics, from everything statistical mechanics, which is like for anybody at undergraduate, you've studied thermodynamics, where you're trying to understand heat and the movement of energy. In that sense, statistical mechanics takes that to a newer level. So I suppose in summary, studying theoretical physics at the postgraduate level is just just adding more, deeper understanding to everything you've already ever learned, and bringing that to another level. So there's two kind of streams, or maybe actually three kind of streams, I suppose, in theoretical physics. The first stream would be what we have our masters, our higher diplomas, and they will be for people who are looking to transition into physics. So you have a relevant undergraduate degree in some other field, and you want to change, to come across to theoretical physics. So that's where the higher diploma is set at. We then have a master's in theoretical physics, or master's in mathematical sciences. And that's for people who want to progress onwards, who've already had an undergraduate degree in physics or mathematics, and they want to get a deeper understanding or improve their understanding or move it to a different level. So that'll be our next stream. And then our final stream will be a PhD in theoretical physics or mathematical physics. For that, then there are programs for that as well. So that, of course, is research-based. There's a limited amount of coursework in a PhD, and it's almost exclusively a research degree. So they would be the two streams. There is a slight other stream, a master's a research master's in theoretical physics. So that fits somewhere in between the PhD and the actual taught master's itself. In fairness, in theoretical physics, there's multiple career paths you can take. So for example, when I was a graduate student, a lot of my colleagues would have gone into finance, accounting, others into medical physics, and others then into research. So there is kind of two streams. When you're doing any postgraduate, whether it's a master's or a PhD in theoretical physics, you don't really need to decide at the start. What you can do is you can do the courses and figure it out as you're going along, which aspect of career interests you at the end. Whether it is you want to go down to the industrial route or the academic route, both are absolutely open to you. And there's a multitude of opportunities, I would say, in the industrial aspect of it. Like I said, in finance, many of my colleagues have gone into work in finance, but also in other other kind of like offshoots of physics. Medical physics, which requires a lot of and probably becoming increasingly popular. Where we have MRI scanning, all of that technology based on very very acute mathematical techniques, really sought after. And then of course, like I said, there's the academic route as well, where you go on and depends on how far you progress, but up to the lecturer or professor level. So there are a lot of different aspects, and the really good thing about doing postgraduate work in theoretical physics is that you get a very solid grounding in physics, mathematics, but also computing and in problem solving in particular. Employers tend to be very interested in graduate with these skill sets, because you don't have skills in a very well defined area per se. You're not you're not pigeonholed in that sense. You have the ability to be flexible and apply your skills in different areas.